Hey YouTube, what's up, Link? Welcome back to another episode of Coding Session. And this might be the last binary tree video for quite some time. We're going to finally go over breadth first search, or the level order traversal. So I think in the uni-valued episode, which was the last episode, I briefly went over level order traversal, or breadth first search. Now, unlike depth first search, as the name implies, depth first search goes as far as it can. It traverses as far as it can in the tree or graph before backtracking and searching or traversing through other paths in the tree or the graph. It goes and dives as far as it can before backtracking and traversing other paths or subtrees in the tree. And of course, in order, pre-order, and post-order traversals are all depth first search based. And now there's one traversal that we haven't gone over yet extensively, that is, in an episode, which is the level order traversal, or breadth first search. The idea of breadth first search is it's kind of like you're typing a Microsoft Word. I'm going to explain it visually first, which is why I brought up the Microsoft Word example. So you're typing a Microsoft Word, and you start on the top page, and you're typing and typing characters, and you're going from left to right, and when you get to the end of the line, you go down, but you go all the way back left and start on the next line. So that's visually how the breadth first search or level traversal is going to print each node, or traverse through each node and print it out on our output. It's going to do 1, then 2, and then goes back to the 1's root right subtree, and 3. So do 1, 2, 3, 4, 5. We start from the top, and then we work our way to the right, go back to the next line, but start it back to the left. Then 2, keep going to the right. 3, oh, that's the end of that, and go back down, and then 4 and 5. That's like the most basic way I can describe it, with it making sense. It's like you're typing on Microsoft Word, and you're going from left to right, then you go down once you reach the end of the line, and then you keep going until you traversed everything else. So instead of the algorithm diving as far as it can before backtracking and exploring other possible subtrees or paths, if it's a graph, this one, it just goes ahead, whatever level it's at, just prints all those nodes, which goes one by one by one. And this is why this can cause some performance issues versus depth first search, because you're going one at a time, where depth first search, it's going to just dive as far as it can, then backtracks, and then explores everything else, and it tends to be a bit faster. So the algorithm, we pretty much are going to print each level one at a time, and that's going to be one method, and the other method is going to take us to the next level. And then of course the first method is going to print the nodes in that level, and then again go to the next level, then print the nodes in that level, and keeps going on and on and on. We also have another method to go ahead and get the height of the tree, which is going to be used in print level order, that method. So here we go, we have our tree. I'm going to have to use my video here. So this is the tree visually. This was the tree in episode 12 here, and of course this was a lovely visual I made. So it's going to be 8, 1, 10, 8, 1, 0, 2, 10, 9, 11. So the level order traversal should be 8, 1, 10, 0, 2, 9, and 11, which is already an output here because I was testing this, but let's go over the code. So we're going to get the height starting from the roots of our tree, and if root is equal to null, obviously return 0, else we're going to recurse, do the recursion with the height method with the left subtree and the right subtree. And what this is going to do is it's going to traverse through and pretty much count every single level within the tree, and all the trees, left subtrees and right subtrees. And then we want to use the larger one. For example, in here, this is 1, 2. This is 1, 2, 3. So we're going to want to use the height of 3 and not 2, because then we won't be able to traverse everything. So we check which one is larger. So if the left is greater than the right, we're going to obviously use the left's height. If not, we're going to use the right height. Then we do our int I, and then we do a for loop with the height that we got from our height method, which was a recursive function. And if for, sorry, I had a minor disruption there. So for int I is equal to 1, or I is equal to 1, I is less than height, which is what we got from the recursive function of height traversing all left and right subtrees and seeing which one was bigger. I plus plus, print given level with tree, which is the first root, which is our tree, the root of the actual tree, the main root of the tree, and I, which is the current level. We go down here, print that given level. If root's equal to null, obviously return. If level is equal to 1, and this is gonna check if we're at if the level is equal to 1. If we're at the current level, we're gonna go ahead and actually print the data. Else, if level is greater than 1, we're gonna traverse through the left to the right and do level is equal as minus 1. So eventually we get the second case, which is level is equal to 1, which will print each node. It's a little confusing. I do think depth first search is a little bit better or easier to understand. It's a little bit more cleaner, as we see in the uni-valued example, and in my the episode where I went over the Ketos project, open source project that I'm part of at my university. So if we run this, we'll see 8110.02911, 8110.02911, which is the correct level order traversal. And that is breadth first search, or the level order traversal of a binary tree. So if you have any questions, or if you want me to clear any explanation up, please leave a comment down below, and I'll try my best. So thank you guys for watching, and yeah, have a nice day. Hey guys, I just wanted to add this to the end of the video, just kind of explaining breadth first search in just a very simple, brief explanation, just in plain words. So breadth first search pretty much starts at the root of the tree and explores all its neighboring nodes at the current depth it's on before moving on to the next depth. So one by one each level, unlike depth first search, dives as far as it can, traverses as far as it can before backtracking and exploring other paths or subtrees. Breadth first search explores all the neighboring nodes at the current depth and then moves on to the next depth. So I just wanted to add that in, kind of an explanation of breadth first search, just in plain words. So thank you guys for watching again, and have a nice day.